What is up, mathletes? So what we're going to look at is how to graph these linear inequalities, and we're going to look at a system of linear inequalities. So that means that you're going to have two or more inequalities that you're going to be graphing, and then I'm going to show you how to get your final answer. All right, so let's start with this. So what I tend to start with is figuring out if it's going to be a solid or dotted line. So because it's y is greater than or equal to, right off the bat, that tells us that we have a solid line when we're looking at this inequality. So we have our slope of 3 and our y-intercept of 2. So let's get started. So here's our y-intercept of 2. I go up 3 over 1. All right, so with that said, let's go ahead and connect those two dots there. And let's create our line. And we said this line is going to be solid. All right, so there's our line. And what we have to do is we're going to figure out what side do we shade. Do we shade this side up here or this side down here? So what you need to do is we take a test point. The easiest test point to use, as long as the line does not pass through this test point, is 0, 0. So here's my test point, 0, 0. That's my test point. So all you do is you plug it in. So we get 0 is greater than or equal to 3 times 0 plus 2. We have 0 is greater than or equal to 2. This is false. So whenever we have a false statement, what you do is you look at where that test point is and you shade the opposite side of the line. So for this case, we're going to be shading the opposite side of the line. So we're shading everything up here. All right. So if it were true, we would shade the same side of where the test point lies. We would shade everything down here. All right, so let's do the same thing for this inequality. So my slope is -1, my y-intercept is -2. So let's do this. So -2, and then I have, what do we say, down 1 over 1, down 1 over 1. Once again, check it out. This is a solid line because you have the or equal to. So if it has that line underneath, you know it's going to be a solid line. And so let's go ahead and connect those dots right there. And so let's do this. And then right now I'll move that line. I'll just make it longer and then we'll move this line. All right. And let's go ahead and indicate it's going to go on forever. All right. Once again, we need a test point. So like I said, always test the point 0, 0. And so this is our test point. If our statement comes out true after we plug it in, then you shade the same side. If our statement comes out false, you shade the opposite side. All right, so let's plug it in, and you end up with 0 is less than or equal to -0 minus 2. So 0 is less than or equal to -2. That is false because 0 is actually bigger than that negative. So because it was false, we're going to go ahead and we're going to shade the opposite side, everything down here. All right, so now we have our two regions. So if you notice, let me go ahead and group everything together. What we're looking for is when we're graphing the combination of the two. So let's look at the combination, the combo of those two, right? We just did, look at question 3 here. And let me shrink it so you can see. Question 3 here is saying now graph both of them on the same graph, right? Graph both of these inequalities on the same graph. And where on the graph are the solutions to the system? So what we're going to be doing is we're going to take each one of these graphs and we're going to place it on this new system. So let me go ahead and do that. Let me do this one in blue. So we started at 2, and then we went up 3 over 1, All right, this is the work that we already did. Let me go ahead and graph my line. And then we already did all the hard work. And so we decided we're shading everything that's above that line. All right. And then we go ahead and copy what we had in number 2, which is -2. Oops, let me use my other pen. -2. And then it was down 1 over 1. And that was also a solid line. So let me go ahead and connect those two. And we shaded everything below that. So we shaded everything below that. So our final solution here, our final solution set is this region. And let me make it really dark. So let me shade the region that got shaded twice. So this entire region that I'm working with right here, this is our final solution set. So what that means is that if you pick any point, in this region here and plug that point, one point at a time, plug it into both of these inequalities, it's going to satisfy the system, meaning it's going to be true. Each statement will hold true. And that's what we're looking for. We're trying to figure out, hey, what's the group of numbers that when I plug them in, right? What are the group of points when I plug them in? It'll give me a solution. So let's fill this out. Look at number 4 here. So the solutions of a system of linear inequalities are and here's our choices, are ordered pairs. So let me grab that ordered pairs. So are the ordered pairs that are solutions to all inequalities in the system. Like I said, you could have 2 or more, right, to all inequalities in the system. So on a graph, the solutions to a system of inequalities is the intersection, right? It's where they intersect. So it is the intersection of the half planes where the shaded regions, notice what the shaded regions did, they overlapped. So they overlap, just to help you with your understanding of this. All right. So what you're going to be doing here on this worksheet is you're going to be doing exactly this, because I want to make sure we understand. So here's your problem. All right. Your problem looks just like this right here. And let's go ahead and let's choose. I want you to do, not all of them, number 7 here, number 9, and number 10. All right. What's not nice about number 5 is, notice, I'll kind of start you off even though you're not doing it. Look at this one. This is much easier, but it kind of throws people off. This right here. Let me zoom in so you could see. All right. So if we notice, there's no y value, right? It's just x. So whenever you have an x variable and there's no other variable, there's no y value, what this means is you're going to have a vertical line. And the vertical line is going to be at 2. And so let me show you. So we're going to have a vertical line at -2, excuse me. Oh, let me get my line back. So at 2, -2. And so it's just going to be this vertical line. And look what it says. X represents all the x values that are larger, that are bigger than -2. So I could shade those. That's all these values here. These are all the x values that are larger than -2. And what I'm going to do is I'm going to make sure that I highlight something. Let me erase something. Because this line right here cannot be a solid line. This has to be dotted. Come on, eraser, work for me. It's okay, I got an idea. I'll just override it with my white pen. So there you go. So I'm going to make sure that this blue line is dotted. All right, so it's a dotted line. Again, it's dotted because our inequality is purely greater than. It's not greater than or equal to. So that's why it's a dotted line. Now we could do this one. Notice we start at 2. We start at 2 here. And then you're going to go up 1 over 2. So up 1 over 2. And then this one is actually going to be a solid, right? A solid line because it's greater than or equal. So let's go ahead and let's do that there. All right, and we do a test point. So let's test the point 0, 0, right? Easiest point in the world. So if I plug in 0 to both of these, this disappears, this disappears. So you get 0 is greater than 2. That's a lie. So we shade everything on the other side of that. So we shade all this up here. So once again, what are we looking for? We're looking for the area that got overlapped in the shading. So all this region here, right? All this entire region, and it goes on forever, right? Any point in that region would satisfy this system. It would work. Meaning, if I were to plug in a point in the shaded region, say 0, 3, if I were to plug it in here, it would be a true statement. If I were to plug it in here, it would give me a true statement. So it would be a solution. And that's what we're looking for today. We're looking for the shaded region. So, let me undo that. And let me grab everything and group it. All right. So what I want you to do, again, work on those numbers, number 7, 9, and 10. And this will make sure that we really understand what the heck is going on. All right, best of luck.